But we knew that that kind of an attack surface that was focused on physical point of sale systems was going to move to the online world, the e-commerce world. And then we started peeling the onion and said, well, how is the web protected today? Is there a vulnerability? And that's when we started discovering all the kind of various issues that I just mentioned about the web having changed architecturally and people still using 15-year-old technology.
Let me ask you about that, because the 15 years ago, many of my listeners are going to get that. And so you had a traditional web server, then you had an app server, database server, and then we used to put a proxy or some type of a WAF in front of that web app. It's still used today. Web WAFs you use in front of these web applications. So you're saying that the JavaScript would execute on that web tier or in the app tier in the old days, and that what you're saying that has shifted. And I think that's an important point you're making. And so where is it shifted to? Like what does a modern application architecture look like today for those that just really want to understand that?
Yeah, I mean, in a nutshell, I think you captured a lot of it. But if you think about the web, there are three elements. There's the web server side, which has a database attached to it. Then you have the network that connects the server, and then the client, right? Historically, as you said, and this is always a pendulum. It swings back and forth. 15 years ago, a lot of the code execution and the data storage was on the server side. That was useful for many reasons, but it did make for an interactive web experience, right?
Sure.
You don't want to make multiple round trips and go fetch data from the server and things like that. So Google came up with technologies like JavaScript, the V8 engine, Ajax, asynchronous, retrieval information, etc., that made things a lot more interactive. I mean, I remember when I used to be a MapQuest user, and then Google came out with Google Maps, and you saw how you could move things around. All of those things were possible because more and more of the code execution was shifted from the server to the client side.
To the browser,
right?
Okay.
Yeah. Now, when you had a lot more of the server compute and the storage happen on the server side, it made a lot of sense to protect your server and the databases that sat behind it.
Sure.
But as the shift happened towards the client, the browser now becomes the point of execution of code. And in fact, the modern browser actually has its own database, right? Not just an app cache. It has its own IndexedDB, for example. People are storing more information locally so that you could actually see instantaneous results of your actions on the screen and then make kind of, asynchronous calls to the backend to update databases and things like that. So the main shift that has happened is the browser is the point where code executes. It's also the point where there's data storage. And because of the incredible competitive nature of e-commerce and online retail in general, marketing teams spend a lot of time putting in not only first-party code, but also third-party code, right? So the data that's executing in your browser is not coming from your e-commerce store, your bank. Most of it actually comes from marketing tags, advertising, lots of very, very critical things that e-commerce companies and digital media companies need for their business to survive, that as a result, your website is no longer running on your code. Maybe 20% of the code is actually written by your developers, 80% is coming from third parties. All of this opens up a completely new set of vulnerabilities that you simply cannot solve by sitting on the server side. You need something that is actually monitoring actively what's happening on the browser, understanding is there anomalous behavior, is there malicious JavaScript, and if so, what is it trying to do, and being able to detect and block it in real time at the browser.